Hello everyone, good morning. In aircraft structures 2, unit number 2, shear flow in open section, problem number 6. So in this lecture we are going to solve the problem. Find the shear flow and shear center with the line of action of force V is given for open tube. The area A is equal to B equal to 4 cm square and C and D booms are 2 cm square. And this is skin is ineffective in bending, right? So we have A boom, B, C and D. The load V is acting in a angle of 45 degree and load will be 1414 Newton, right? So this is absolutely unsymmetric one. So area of A boom will be 4 centimeter square, B will be 4 centimeter square. C will be 2 centimeter square and D will be 2 centimeter square. So if you want to split at any x-axis or y-axis, it will be unsymmetric one. You cannot split into a symmetric one. So this is curved web with a radius of 15 centimeter. It means the A to B distance will be diameter. So the length will be, we are getting 30 centimeter height, right? So we got this. So the given data, we go for the given data. Given data will be S of phi. We need to find out the, so if we shear for S of x and S of y, we need to find. So instead of S and y, they are given as in terms of V. So we need to split this as into two components. One is horizontal components, one is vertical component we need to find with respect to angle. So it will come Vx, so it will come V is certain V. So we will get Vx, this is Vy. So I already told in the problem, if you want to find Sx and Sy, Sx, kind note down, Sx will be V of x, that means this V of x. So V of x will be in terms of V cos 45. Right? S of y will be also called as this Vy. Vy if we found with respect to angle V sin 45 degree. Right? You substitute V is equal to 1414 into cos 45 will get do cos 45, what is the value? Cos 45. So you have 0.707 into the answer 1414, you will get nearly 1000, 999.8. So let us consider as 1000 Newton is acting in as a SY. So Sx is the same, 1414 into sin 45 you will get sin 45, you get again this 0.707 into, if you get the same, I think you will the same value. So you will get again, so 1000 Newton is SY. So this is a boom structure. So we no need to calculate ICX is equal to ICY will be 0. So no need to find the element table. So element table, we find the element table. So we have the elements. The element is, so kindly note down, element. We have A, B, C, D, and we have to do the summation of these elements. For that, you need to calculate what is the area of each element, what is the x reference axis, what is the location of y. Then Ax you need to calculate, Ay, Ax square, Ay square, then Axy. Right? We know all the area value. This is 4 by 4. This is 2. So we'll get 10 for, we'll get the totally 12 summation for the area. X will be, if you take reference, this is axis x, y. So axis will be, reference will be 0 for the element A, 0, y will be 30. That's why we found the diameter. So 0 for B 0 for B for Y. For the distance it is there in 40 comma 0 Y. 40 comma 20 is that for D. 40 comma 20 for the D. If you add this, you will get 80 summation 80. This is around 50. If you multiply, AX will be A into X will get 0. A into X will get 0. This will be 80. This will be 80. And AY, this is for 12. 12 0. You will get 0. This 0. This 40. So you will have this if you have 160. This is also 160 summation. So remaining time you need to do this 0 0. You will get AX square, you will get 3200. Again you will get the same 3200. 6400 you will get. So again you will get 3600 for AY square. Right? AY square. This is 0. Y value is 0 0. So you will get 800 here. Again you will get 4400 for AY square. So A into XY 0 0 0. Again this 3 times this you will get 1600. If you do the summation, again you will get 1600. So we calculated elementary table for this boom structure, right? We find out that A, X, Y, AX, AY, AX square, AY square and AXY. For the each element, for each boom element, A, B, C, D element, which is unsymmetric section, it is open section, right? So you kindly note down the summation values properly. This is boom structure, so no need to calculate ICX, ICY. If you want to calculate that, you get 0 value, right? Definitely you get the 0 value. So now we move on to the remaining time. In moment of inertia we will calculate. So before that we need to calculate what is the X bar and Y bar for this problem, for this original diagram. So we need to find out the X bar and Y bar. X bar equal to summation of AX to the formula, summation of A. We have the summation of AX, summation of AX is 160, summation of A will be 12. So we are getting 160 divided by 12. That means you are getting 13.33 from the reference axis. You are getting the x-axis value. So y bar also summation of AY divided by summation of A. Summation of AY will be 160, again 12. You are getting the same 13.33. That means from the reference axis X bar 13.33 centimeter, you have the X bar, and up to Y bar will be 13.33. That means the point will come here. So you have your X bar comma Y bar value. That is what we are finding the real centroid value for this open section, right? That is the location of the centroid. Now we need to calculate IXX for this section. What is the IXX formula? So IX is equal to summation of AY square minus summation of AY bar square. So we have summation of AY square, we have summation of AY square in the element table if you have the value. So we have 4400, the entire square value, minus summation of A we know, into Y bar square. Y bar we calculated 13.33 whole square if you do means. So we are getting 13.33 square root of, and into multiply with 12. So you have to minus 4400 minus of the you are getting value, and you are getting 2267.7332. So you are getting the IXX is 2267.7332 centimeter power 4. Similarly, you need to find out the remaining term IYY. What is IY formula? Summation of AX square minus summation of AX bar square. So X square summation is we have the AX square, so 6400 minus summation of A12. X bar also same value you will get. So 13.33 the whole square. 13.33 the whole square. Then if you do that, you will get the 4267.7 centimeter power 4. So I became the same value, only the 2000 value, so I am adding the 2000. So we calculate Ixx, Iyy. Now we need to calculate the Ixy is equal to summation of Axy minus summation of Ax bar y bar. So put all the values. Summation of A is 1600 minus Ax summation of n12. This is x bar 3.33 into 13.33. If you do the calculation, you get this is 1600. So 12 into 13.33 into 13.33. So you are getting 2127.46 minus of 600. So it is minus, so minus 527.468 centimeter power we are getting for the Ixy value, right? So we have the Ixx, Iyy. So we need to calculate the what is the x bar and summation x bar and summation sx bar and sy bar. So for the shear flow formula we know, kindly remember this shear flow formula. Q equal to shear flow minus will definitely come as per our derivation. Sy bar divided by Ixx summation of Ay minus Sx bar divided by Iyy summation of Ax. This is your shear flow formula. So we calculated Xx, Ixx, Iyy. We know summation of A. For each boom area we know. For each boom Y location we know. Similarly for each boom we know A and X value. So we need to find out Sx bar and Sy bar. For that we know the separate formula. Sx bar equal to Sx minus Sy Ixy divided by Ixx divided by 1 minus Ixy the whole square divided by Ixx Iyy. So kindly remember this formula. Now you apply the value here. What is Sx? We know 1000. We calculated, right? So Sy was 1000 and Iyy equal to minus of 527.27 divided by this minus, kindly remember, this is 2267.7 whole divided by 1 minus 5223.27 the whole square whole divided by 2267.7 into 4267.7. So we have this value for S. If you solve this value, so I'll do the calculation here. First, whenever you solve the problem, try to solve the complex term first. So I'll do this first. 527.27 divided by 2267.7. So I got this value. We have minus into 1000. So answer into 1000 we are getting some 223 point. This minus will cut. Plus, then you have to add with this value plus this 1000. This is the top value. That means 1232.513. This is the top value, right? Now we go for the bottom value. We have the minus 532.27. If square it will get the same value, positive value. So you get square it off. So we need to divide it by. You have to do the division into 2267.7 into 4267.7. So we are getting this two term in division of 1 minus this 0.0291. So if you do 1 minus the coming answer, we are getting 0.9797. So we need to divide 1232.513 divided by answer what we got is 0.970. So we are getting the value of 1269. So we will write as 1270 round of value. We write the 10740 in terms of Newton for Sx value we got. Similarly for Sy value, similarly for the X6 bar Y value, so we need to calculate that also, right? here we are going to sy bar equal to sy minus sx I xy. I am writing the formula to understand, to recall your the formulas. That's why I am writing whenever I am writing. Exam, you also write it out. Then only you will not make any mistakes while solving the problem. Right? Here also we have the same value, 1000 Iyy we will get 527.27. The only term will change from this to this is Iyy. What is Iyy we got? 4267.7 we need to solve. Divided by the whole term, we know the same value you will get for here also, same value. So you have the 0.9707. Right? Once you solve, you will get the simplest values. So you have 527.27, right? Divided by, you have 4267.7. You got this value into 100,000. So you need to add with this plus 1000 minus plus, right? We are getting 11235.0.9707. So this is similar to the last value, and we have to divide with this 0.9707. So we are getting 1157.46 Newton for sy bar. Guys, listen, we find out what xx bar and sy bar using the formulas. Now you need to get the shear flow formula Q. You have to apply here. So now go for the shear flow. Q equal to, for this general formula, Q equal to general formula, we need to apply the sy bar really. So 11, we have generally in shear flow you have the minus in the formula, minus of 1157.46 divided by Ixx formula, answer you know 2267.7 into summation of a y dash, I mean y bar for each element that we will find later, minus this formula will come 1270, it will come for this case 1270 Newton for SSX6 bar divided by 4267.7 into summation of Ax dash for each element, each boom. This is the final formula. If you reduce it out, you will get 0.511 summation of Ay, 0.298 summation of Ax. You are getting the shear flow for this entire open section. Now we are going to find the element coordinates table, right? Coordinate table. We need to find out. For that, we need for area we need for A element, for B element, for C element and D element. Area we need, X we need, Y we need. For area of each boom will be area we know, right? This is 4 centimeter square for this A. This is also 4 centimeter square. This is 2 centimeter square for this one. And X will be X for the we will take from this diagram. From the centroid you have to calculate for this. I'll take it off here, right, to understand for better understanding, right? So for A, from the centroid it is minus 13.33 and Y will be 30 minus 13.33. From here, what is the Y value for A element? 30 minus 13.33, you are getting positive 16.67. So for B element it is absolutely minus 13.33, again minus 13.33 Y value from here down and this left side. For C element it is around 40 minus, totally X will be 40, that further you have to minus a 13.33, you are getting 26.67 positive, but Y will be minus 13.33. For D element it is same as to this C element, 26.67 and D will be same X and Y will be 20 minus 13.33. So you are getting 6.67 0.67 this d value from this height, this value. We have to calculate for each element, for C, A and everything. We calculate the table, and now we need to find out the shear flow for A to B. We always used to start with A to B, B to C, C to D. Whenever you solve the A to B, while going for B to C, you have to add this A B value, A to B value, shear flow value. Once you go for C to D value, you need to add BC value for the next time. You have to add it up and take out the shear flows, and you have to go out. Right? First, boom, A to B, that we'll write as, first we'll call the boom A to B, that will say as Q A to B. We have the value 0.511. We'll write that formula. Okay? 0.511. 0.511. Minus, I forgot, right? You all don't forget, guys. You write the minus, you don't forget the minus. Once you minus the minus means the problem get wrong. Minus 0.511. This from this only I am taking. For this I am writing here. Right? For A you have to apply. For A area will be 4 into Y. From this table you have to take it out. From this table only you need to take it off. Once you found out the table mean, then it is very easy for the problem. So you have this value, some A, Y will be this, and the area of Y will be 16.67 minus 0.298, right, into some A will be, A will be 4, and X will be minus 13. Don't forget those minus and plus. Right? If you solve this these things, you will get minus 18.18 Newton per centimeter. Right? So we calculated the shear flow for the A to B. Now we need to calculate it B to C. What is the shear flow? So once you go for the B to C, same formula, same equation you have to apply. Minus 0.511. Summation of A for the beam is B is 4 into Y is minus 13.33, minus 13.33. So you have to use the formulas again, minus 0.298 into summation of A will be same 4 for the element B, and Y will be minus 13.33. So if you solve this, you will get, and you are here, guys, remember that for whenever BC goes, the same formula plus you have to add this value here, Q A to B. You need to add, right? So if you solve this by adding this this value, you will get 43.136 minus the QAB equal to minus 18.18. So you are getting 24.96 Newton per centimeter for the shear flow from Q B to C. Now we need to find the C to D. We need to find out C to D. We need to find out Q C to D. We need to find out C to D. For that again you need to add BC value here. Before that you write the formula. A will be 2, and for C element it is Y will be minus 13.33 minus 0.298 into 2, area here 2, and X will be 26.67 plus, guys remember, plus you have to add this QBC value, right? So if you solve this, then again you will get the entire tape. Do the calculation once again. So 0.511 into 2 into 13.33, you will get this as plus value. This is entire time will come 36.23. This will get minus 0.298 into 2 into 26.67. So we are getting 15.8953 plus this value, this QBC value 24.96. So you need to add the entire thing, 24.96 minus of 15.8953 plus 13.623. So you are getting 22.6 68 Newton per centimeter. So this is QD. So now we will draw the shear force diagram for our problem, this problem. So I used to draw the shear force. This is A, this is B. We have curvature here, and this is B to C. This is C to D. These are the booms only we are calculating. A, B, C and D. Right? The load may be acting at somewhere in some angle, that distance we'll find out later. So we have the Q, A to B, Q, B to C, Q, C to D. So this is minus 18.18 per centimeter and 24.96 Newton per centimeter. Again this one will get in 22.68 Newton per centimeter. Right? So this is curved one. So definitely it has this value as this is, I'm saying that this is minus 18.18, that is A to B. I'm getting minus 18.18 shear flow. Shear flow region I'm drawing as like this, and this is 24. So huge value will get. So again this is shear flow B to C. You have to draw this arrow mark 24.96. This is B, C to D we are getting 22.68. Guys, remember I'll draw value as it is. A to B we are getting minus 18.1. Once if you want to change this minus 18.18 as positive 18.18 means you change the arrow. Once you change the arrow, then everything will change, right? So now we need to calculate for the moment about shear center location. Okay, and now shear center location we need to find out where this vertical load is acting, that we already know 1414 Newton. We have splitted and solved, but which location, what is a distance we need to calculate and mean? Take moment about E point, right? That you have to take it out two cases, this and this, vertical Vx and Vy and Vx. You need to solve for each case. So for that a common I'll take as taking moment about I'll take from here B point. Moment about B will be 0, summation of as per the equilibrium case. So let us take the somewhere it is acting this B. In terms of load will be, I am taking vertical load alone. So first we will solve for the vertical load and then we will go for the horizontal load. So only I'll take this vertical load. Due to this vertical load, I am getting 1000 value. This is V sin theta. This is cos sin 45. This is 45 degree. This is V cos 45 degree. Once you change V cos 40, then I am getting 1000 vertical load into distance E. So taking this, already I told, for curved wave the moment will be 2AQ, that is Bredbertho formula that we will see in the third unit. So this is completed. We need to take this will not come and this will come, right? Plus 22.68. I told already you have to take the shear flow and the distance and this perpendicular distance. So 20 into the perpendicular distance is 40. Once you solve this, you will get E is equal to minus 5.2 centimeter, right? For if you want to take the load as it is, load V equal to 1414 Newton means, then the E will be 1414 into E, okay, minus 2 times of this area AQ, the same things will come to 40 equal to 0, then E will be 3.7 centimeter. This is the your shear center location for this problem. So to recalling this problem, kindly note down, this problem will come for your IA1 exam, right? So this is unsymmetrical one, boom structure, curved section we have, open section, and the area is different for the each boom. AB are E4, BC, CD are 2 centimeter, and especially they are giving load in terms of V and with angle of 45 degree. We have to resolve it as two vertical component and horizontal component. So V cos 45, V sin 45. Then if you do this cos 45 and sin 45, we are getting 1000 Newton for vertical and horizontal load. Boom structure, since it's a boom structure, we will not get the ICX and ICY value. So we need to find out the elementary table AX by AX, AY AX square, AY square, AX value, AXY value. If you done this tabulation, then you will go for the X bar and Y bar formula to find out the centroid of that section. So then we need to find the IXX, summation of AY square minus summation of AY bar square. Summation of AY square we have value in the tabulation. Summation of A into Y bar square. Y bar square we find out that if you do, we will get the IXX. Similarly for the IYY we will get the A summation of AX square minus summation of AX bar square. Similarly next we go for IXY equal to summation of AY minus summation of AX bar Y bar. Then we are getting in terms of minus. So we need to finally we need to find the shear flow Q equal to minus. Guys, remember this is very important. You will forget this minus and minus. Minus Y bar minus IXX into summation of AY minus SX bar by IYY summation of AX. Then further you need to find XX bar, XY bar, SX bar equal to S of X minus SY IXY by IXX divided by 1 minus IXY the whole square divided by IXX into IYY. If you substitute all X bar, XX bar, SX, XY value into IXX, IYY, IXY value, you will get SX bar equal to 1270 Newton. Then similarly you need to find out the SY bar. SY bar equal to S by minus S by IXY divided by IYY divided by 1 minus IX square divided by IXX into IYY. If you substitute all the value, you are getting SY bar equal to 1157.40 Newton. So Q equal to, you know the formula, if you substitute here, this is summation of AY, this is summation of AX. You need to apply for the each boom. So before finding this X, Y for the entire formula, you need to find the coordinate table for each boom, A, B, C, D boom. So area, you just put it on this table once doing the calculation, that will be helpful to you. So A, X, Y, you put it out. So you will start from the boom A to B, Q A to B equal to, if you substitute A and Y, you will get minus 18.18. So then we are getting Q, B, C. Once you go for QBC, you have to add the QAB value, and you are getting 24.96 Newton centimeter. Then you go for the QCD, shear for the QCD. QCD, once you go for, you have to QBC, right? So finally you are getting 22.6 Newton centimeter. So this is shear flow diagram. A to B you are getting 18.18 that I have drawn here, and I put the arrow also. Then B to C I put the arrow, I draw a shear flow diagram arrow, and value will be 24.96. This will be C to D, we have 22.68. So we are getting the value. Shear center location I calculated for this is for vertical, this is for VY, this is for VX, directly V. If you want to find VX also, you will find it out. VX will be, this will come. This will be this location we need to find out. This will be EX. EX, we find out this is in terms of EY, this is common EX we find out, right? That is E 3.7 centimeter, right? Thank you.